Good evening, Dr. Asra. We are Ali Al Habibi, Niranjan Koirala, and Srijan Adhikari, and we are presenting our presentation on the report comparison of wide band gap semiconductor for power electronic application in electric vehicles. So our outline for our presentation is shown here. First of all, we'll be talking about what are the needs of wide bandgap semiconductors and the challenges the semiconductor poses in electric vehicle. And then we'll move on to the properties of wide bandgap semiconductors. Basically, we'll talk about three properties here and some of the challenges that we faced using the wide bandgap semiconductor, and lastly we'll talk about the conclusion. So why do we need wide bandgap semiconductor? So as we know that the electric vehicle popularity is gaining day by day. To reduce the emission of greenhouse gas, the government is also promoting electric vehicle, and more electric vehicles are seen on the roads. There are all the manufacturing companies that are researching and developing electric vehicles. Main challenges with the electric vehicle is the charging time and the range it can cover with a full charge. So most of the you can see you can see as in the figure, we have divided the components of the electric vehicles into 5 parts. There is this battery and DC-DC converter along with the DC-AC converter, and the electric motor drives the transmission unit. More in here, a lot of power electronic basically the power electronics components are involved, and these components are traditionally made from silicon, because they were there previously. So what happens is, as we are running the vehicles, more heat is developed, and we want the vehicle less with less weight. So some of the challenges that the silicon semiconductor poses are, it we cannot compact the large power electronic devices into a small one. Hence we have to move into some next option known as wide bandgap semiconductors. They are those semiconductors that have band gap that are much more than the traditional silicon conductors. So they have the properties that can be used to produce lightweight electronic devices, and we can compact many devices into one using high temperature up to 600 degrees centigrade, and with high frequency devices. And we can also use high frequency devices that will ultimately reduce our processing time. So this we can see in the picture that this is one of the example of Toyota Prius EV. So it is using Si silicon carbide as its wide band gap semiconductors, and due to this it has reduced the cost and size by 10 times, and the charging is the electricity loss is also reduced by 66%. So we'll now discuss about, now my friend Al Habibi will discuss about the properties of semiconductor devices, and how they are superior to their traditional counterpart. Thank you.
Thank you, Srijan. Uh, I am Ali Halabi, and I'll be talking about the properties of wide band gap semiconductors. So the first property is wide band gap. Due to wide band gap, electron in the valence band need more thermal energy to move the conductor band. So the wide band semiconductor have the advantage of high temperature operation and more radiation hardening. If you can see here, the band gap energy of silicon is 1.1, and the one of silicon carbide and gallium nitride is about 3 times 3.3 and 3.4. So the second property is the high breakdown field. Wide band gap mean a larger electric breakdown field. a higher electric breakdown feed result in power devices with higher breakdown voltage. So at the same breakdown voltage, the device made by wide bandgap semiconductor can achieve much higher doping level and have much thinner device layers. The higher doping level also lead to lower on resistance of wideband semiconductor device. Third point is the high thermal stability. Wideband semiconductors material also have high semiconductivity, so the material conduct heat to its surrounding quickly and the device temperature increase more slowly. The temperature of the device is robust against temperature change, time, and reliability. The final point is the high saturated drift velocity, the high frequency switching capabilities of semiconductor material is directly proportional to its drift velocity. High drift velocity allow a shorter reverse recovery time of the diode during the switching, and thus it will lead to lower switching losses.
Thank you, Ale. I am Niranjan Koirala and I will be talking about the challenges that will be regarding wide band gap type of semiconductors. The primary concern for every industry is always about the cost, and the cost for these types of semiconductor has always been high. In addition to that, excessive heat is produced in wide band gap semiconductors due to the packaging problems, even though they have a high operating capability during the higher temperatures, but due to the packaging problem, we have excessive heat generation. Along with that, the simulation models that we will be designing in different kinds of software shall be shared for further research and development. While concluding, wide bandgap type of semiconductors has shown very high potential for higher power operations and high speed power conversions. In addition to that, because of its characteristics like high speed switching, low conduction loss, high operating temperatures, and also because of its small size, different research area for the power electronics field has been opened up. But because of the high switching characteristics of this type of semiconductors, unexpected behavior during the operation is shown by the passive elements, and which needs to be further researched upon. Thank you.